Hi, welcome to this lecture on adaptation for animals. Now we are focusing on somewhere where we are not using the respiration. So in the previous videos we've been discussing that how we are moving the oxygen and carbon dioxide in the normal daily life when there is oxygen available, etc. But then, what about then if there is no oxygen, like in diving? First of all, we have pre-consequences of a diving reflex. That happens in all terrestrial animals, and actually it happens also in the fish if they are not having oxygen available. First of all, there is apnea. So the respiration is inhibited. You can see that there are still some open questions on which brain area this regulation is coming from, but anyway, we know that how it's regulated. Then we have bradycardia, so the lower beat rate. So maybe from 80 beats per minute, we are reducing then the beats per minute in the heart, and that will of course then reduce circulation. Then the third one is on the peripheral vasoconstriction. So we are getting the blood vessels smaller, at least in somewhere. It's in the skin, in the liver and the kidney, and there's focused on the essential organs. So we close the circulation in certain organs so to support the circulation in others. And of course, if you are not having the circulation in an organ, then there's an accumulation of lactate and other metabolites. And that can cause, of course, the problems. Let's look first on what happens on the human apnea. So when holding the breath, for a short while it's not difficult, but then little by little you can't do it anymore. And in this experiment, this man has been testing, he's been quite well doing it almost 8 minutes. But at the same time, you can see that there's a difference in the skin color, and the blood is actually turning black. Why it's turning black? It's because in the beginning there is a lot of oxygen, and in the end there is not much oxygen anymore. So there is a hypoxia. And at the same time there is an accumulation of carbon dioxide, so there is hypercapnia, and they are together then step by step forcing this man to breathe. Okay. One thing that happens is then this bradycardia. And this is interesting that, it's not only related that, we are underwater, but the temperature is important. So in warm temperatures, this might be 10% decrease. So if the regular beat rate is 8 beats per minute, now it's perhaps a little bit more than 70. Then, if it's in quite cold water, this might be decreased from the 80 to perhaps 60. So there might be 30% decrease in the heart rate, etc. So it's a little bit more complex than just on the holding the breath. So we are also getting the temperature information. So what about then? We humans, we think that we are quite good divers, but we have animals that are much better. So in a typical human, we are suffocating within 3 or 4 minutes. And the recording in the static apnea is actually 11 minutes, but this apnea is of course meaning that he or she is not doing anything else than just holding the breath. So, and that's completely different thing that doing the active diving. But these diving marines, they can survive hours under the water. So there must be some difference in these bodies. And the difference is not that, okay, they have completely different kind of brains. So why we die in when not breathing is because of the anoxia in the brains. That's not enough. 20 seconds is enough to cause the unconsciousness. So we are not responding on much anything. And that will stop the electrical activity in the brains. And that will cause the death. But these brains of the seal, they are not completely anoxia tolerant. So they must get oxygen during this long distance and long lasting diving. Oh, one thing that is different and why it's a little bit difficult to measure is that these animals are not all the time diving, and it's difficult to get any sensor on, for example, to measure. And therefore, in the early studies, they were using forced diving, like anesthetic animals that are putting underwater to see that, okay, what happens to the bradycardia, etc. And in these modern studies, there's a data logger that can measure both the location and the deep of the diving in the freely moving animal. So they are wandering there in the ocean and going sometimes into quite deep. And the good one in these data loggers, they can also record several physiological responses, like how much oxygen there is, how much carbon dioxide you have, heart rate, etc. So you can have more information than just where this animal exists. And the interesting thing is that, okay, when it's moving, then it's of course increasing the metabolic activity. And that's affecting on all the responses. Okay. Usually these good divers are not doing the extreme. So 70% of these dives are less than 200 meters deep. Although this animal can dive all the way till 600. So it's not doing the extreme. And most dives are lasting less than 20 minutes. Although this animal can dive also 60 minutes long. So they are not doing the as long as as deep diving as possible. So they are minimizing these extreme activities. One interesting thing is that, okay, when it's diving to 600 meters, that's quite much like the pressure of 40 atm. So 40 times higher pressure than we have in the atmosphere. So that is modifying quite much the body shape, for example, of this animal. Okay, one way to measure is to use these satellite receivers. So when you have this satellite receiver, then you can leave it to move freely on wherever it wants. And in these elephant seal experiments, they've been using a animal called moo, and you can see that most of these dives are within 200 meters. But in some cases, it can reach 700. And then we can see that there is also large variation on how they are migrating from the California coast to this center Pacific Ocean. So the males are on these red ones and the females are then on these yellow ones. They're migrating a little bit different ways, and there might be also quite much difference in between the individuals, so how deep they are diving, etc. So not all the same. Thank you.